In today's video, we're going to learn how to find missing angles in a right triangle using inverse trigonometric functions. So we'll look at this first diagram on our notes. We have a right triangle with the angle here, right angle here, and sides of 12 and 13. We're going to be looking at finding this missing angle represented by the Greek letter theta. So essentially just a zero with a line through it. Imagine it like an x in any other equation you solve for. We're solving for it like we usually do using inverse operations. So based on this angle, do we use sine, cosine, or tangent? If I were to label 12 and 13 based on the angle, 12 would be my opposite, 13 would be my adjacent, and this side over here that's blank would be my hypotenuse. As you've learned, you cross out the hypotenuse and you're not going to use that side length. And looking at SOHCAHTOA, the only trig function that has no hypotenuse in the ratio is going to be tangent. So we're going to use tangent in order to find a missing side length, missing angle. Apologies. So we're going to set up the equation. It's going to be tangent of the missing angle theta is equivalent to, and it's TOA, so it's O before A, so opposite over adjacent, so 12 over 13. Now finding the missing angle. Some kids usually suggest let's subtract or divide by tangent. The problem is you cannot do that because it's not tangent times theta or tangent plus theta. It's tangent of theta. So what you have to do is what's called inverse tangent. So you do the inverse tangent of the side length ratio to get what theta is. So essentially the theta and the side length ratio will swap places. Now this is what you type into your calculator to find out how many approximately degrees that angle is. So typing this in, the buttons for it are here. So tangent is in white, inverse tangent is in blue above it. So press second tangent, 12 divided by 13. And you get 42.71 degrees. Now I already checked this before off camera, but always make sure that you press the mode button to ensure that the degree is highlighted and not radian. And that's it. We have found the missing angle in degrees using inverse tangent. In this example down below, we have a right triangle with all three side lengths given. We're going to find out what sine theta, cosine theta, and tangent theta are in ratios, and then we're going to find the angles for each one of them using inverse sine, inverse cosine, and inverse tangent. So from this angle theta, I'm marking 4 opposite, 3 adjacent, and 5 hypotenuse. Opposite is across from the angle theta, adjacent touches the angle, and hypotenuse is across from the right angle. So sine, starting with an S, followed by OH, so opposite over hypotenuse, 4/5. Cosine, CAH, and SOHCAHTOA, so it's adjacent over hypotenuse. And then tangent is TOA, that's O over A, so 4 over 3. So we're going to do the inverse sine for this first one. So theta is going to be equal to inverse sine of 4/5. So in our calculator, we're going to press second sine to get that sine with the -1 notifying you that's inverse sine. 4 divided by 5, enter. So 53.13 degrees is my theta. If I go over to cosine now, theta is going to be inverse cosine of 3/5. So back to my calculator here, I'm going to find second cosine, then 3 divided by 5, and I'm going to find out that theta is, again, 53.13 degrees. And you probably should have predicted at this point that if I do inverse tangent of 4/3, I should get 53.13 degrees. So let's check. Second tangent, 4 divided by 3, enter, 53.13 degrees. So no matter which two sides you use, every inverse trig function, depending on the two sides you choose, will produce the same theta in degrees. Okay? So your tasks are going to be finding missing angles in these triangles given 2 or 3 side lengths. So we'll do one example up top here, and then we'll do one of the story problems. So the top right one we'll do. It says to find theta, that angle, given that this side length is 7 and that side length is 10. Well, off the bat, I know across from the right angle is an hypotenuse, and the opposite side is here from the angle, which means 7 is my adjacent. I'm going to cross off the side I have nothing to do with, or the one that's blank. So I'm not going to use any trig function that has an opposite. So that means for SOHCAHTOA, the only trig function that has no O in it is cosine, CAH there. I'm going to go ahead and write that up here as well, so you have it. So I'm going to use cosine of theta, and that's going to be equal to A over H. So it's going to be 7 over 10. And we're going to use inverse cosine to find theta. So inverse cosine of 7 over 10. So second cosine, 7 divided by 10. And we get an angle of 45.57 degrees. So the setup is the same as the last two standards on trig. We have a trig function, then an angle, then a set of ratios of sides. So what I've written on the board before, you have a trig function in front, angle goes inside of it, then side ratio here. Except now we're solving for this piece versus one of these two pieces. So what you do is use inverse trig to find those missing angles. Let's do a story problem, and then we'll end the lesson. All right, so the last one here. A 32-foot tree is casting a 22-foot shadow. What is the sun's elevation at that time? Round to the nearest tenth. So drawing a right triangle, we should know by now that the shadows appear on the ground, and the triangle is drawn in a way that the horizontal portion is on the ground. So 22 feet will go down here. 32-foot tree is describing the height of a tree, and height is a vertical measurement. The sun's elevation at the time. Elevation, I want you to think of angle of elevation. So angle from the ground up. So from this angle here, I have 22-foot shadow and a 32-foot tree. They want to know what the degrees is for the angle that's given right there for elevation. So marking these, hypotenuse is here, 32 feet is going to be my opposite, 22 feet is my adjacent. I'm crossing out hypotenuse, it is blank. The only trig function that has no h or hypotenuse next to it is going to be tangent. So tangent of theta is going to be equal to, and it's TOA, so O before A, so opposite over adjacent. So theta is going to be equal to inverse tangent of 33 over 22. So typing that in, second tangent, 33 divided by 22, and you get 56.31 degrees after you round it. So nearest tenth would be just 56.3 degrees. And that's your missing angle of elevation to the sun. So to recap, we're using the same equations before, except now we're looking for this portion, and we utilize our inverse trig functions that are above sine, cosine, and tangent on our calculator. And we access those by pressing second, then sine, cosine, or tangent, and then typing in the side length ratio into the inverse trig.